Okay, so this is classified polygons, and it's a real simple lesson. But first off, we need to know what a polygon is. So a polygon is a figure of 3 or more sides that connect at vertices. And vertices, I know we haven't seen that word before, but basically it's just the plural of vertex. Okay, and we know what vertex is. Vertex is always a corner or where the 2 endpoints of an angle meet, right? But now we're using it as far as polygons are concerned. So I have 4 examples here: circle, this weird little shape here, the triangle, and the, what is that? That is a pentagon. 1, 2, 3, 4, 5, 6. Sorry, that is not a pentagon. But it is a polygon. And the reason it's a polygon is because it has straight sides. And that's what sides need. They need to have straight line segments. Okay, so that's why these are polygons and these are not polygons, because these have no straight. This one has no straight lines. It's a circle. This one has a couple or 3 straight lines, but it has that curve up at the top, and that's what makes it not a polygon. Okay, because it doesn't have all straight sides. Okay, we also have convex and concave. Okay, so what I want you to do is I want you to come up with your own definitions for these, and I'm going to tell you which ones are which. Okay, so a convex shape would be this one here. Okay, so this is a convex shape, and the reason it's a convex shape is because if I imagine this line continuing on forever, it's never ever going to cross through the middle of the shape, and that's what makes it convex. Okay, concave is when it will cross through. See, if I put this here and I imagine this line going on forever, that line cuts right through the shape, and that's what makes it concave. Okay, so that's the difference between those two. I'm going to ask that you come up with your own definitions for these. Okay. We also have regular polygon, and that's simply a convex, equilateral, equiangular polygon. Okay, so in this case, equilateral we haven't gone over, but I am going to expect you to know what it means, as well as equiangular. Okay, these are 2 definitions I want you to find on your own, but if you follow along, you should be able to figure out what these mean. Okay, so again, regular polygon, a convex, equilateral, equiangular polygon. So here I have an example. This is a regular triangle, and it's regular because it has all 3 sides are the same length, or equilateral, okay? As well as all 3 angles are all the same measure, okay? Equiangular. This is not regular, okay? And it's not regular because even though these are congruent to each other, these sides are congruent to each other, but not all 4 are congruent. And because not all 4 are congruent, it's not a regular shape. Okay? There's only one type of quadrilateral that is regular, and that would be a square. This is obviously not a square, right? That's a rectangle. So let's look at some examples. First one, it says, find the perimeter of each shape if each shape is regular. Excuse me. So again, if I assume that this shape, is a triangle, is regular, I can go in here and mark this shape up. And again, remember, these little marks simply mean that all the side lengths are exactly the same. Okay? And if I know that this one side length is 5 centimeters, since it's regular, I know that the other 2 are also the same length. So this should be 5 centimeters, and this should be 5 centimeters. Okay? So once I've done that, finding the perimeter is real easy, right? Because the perimeter is just basically adding all the side lengths together. So if I do that, I get 5 plus 5 plus 5. I get what? 15 centimeters, right? Same with B. It says, again, it's a regular shape, so I know that all of these side lengths are exactly the same. I also know all the angles are exactly the same measure. But in this case, since we're dealing with perimeter, I don't really need to worry about that. Okay? But if each one is 13, I could do the addition, but I got a lot of sides here. So another way to do perimeter is to do what? is to multiply. So I could say 13 times the number of sides, right? So you just count 1, 2, 3, 4, 5, 6. So 13 times 6 is equal to P, or P is equal to 13 times 6. And 13 times 6, let's see, I always like to split it up. I do 6 times 10, that's 60, and then 6 times 3, well, that's 18. So 60 plus 18 is 78, right? All right. So, example number 2, again, says find x if each shape is regular. So again, the fact that it's regular, I know that all 3 sides of this triangle are congruent, okay? But I don't care about the perimeter this time, I just want to find x. And if I know that this side length is equal to this, and this side length is equal to that, what I'm going to do is I'm going to say, well, I know that those side lengths are actually congruent. So I'm going to set them equal to each other. Okay? So if I set them equal to each other, I see that I can easily solve for x now because I have just a simple algebra problem. And I'm going to do 2 steps in one. I'm going to move x over, and at the same time, I'm going to move over the 10. So numbers go that way, x's go this way. It could be the other way around. It just happened that more x's were on this side of the equation, so I want to move them this way. So 15 minus 10, I get 5. This becomes a big 0, and this becomes a big 0. 2x minus x, I get x equals 5. All right, so with B, I know that the perimeter equals 44, and I know that each side is x plus 4. And again, the shape is regular, which means that I know that all 4 sides are exactly the same length. So this is x plus 4, this is x plus 4, and this is x plus 4. So again, I could add them all together, and actually I think I'm going to do that. I'm going to say that 1, 2, 3, 4, 4x plus 4, 8, 12, 16 equals 44, because that's the perimeter. Okay? So now that I have my equation, I can easily solve. I'm going to subtract 16. And I'm going to move my answer over here. We're running out of space here. 4x equals 44 minus 16. Well, that's going to be 28, right? Divide by 4. X equals 28 divided by 4. 4 goes into 28 7 times, right? And there we go. I just solved for x. That's all it was asking me to do. All the problems that you're going to deal with are going to pretty much involve any of this. It's also going to ask that you classify the polygons. You need to know convex, you need to know concave, but you should be just fine. So with that, this has been Classifying Polygons.